Hello, everybody. So this video here is going to be the lecture 2 that's from week 8, despite the fact that it's actually Tuesday, week 9. So I have to record 2 lectures today, but this one's more important, so we're doing it first. So this is the week 8 assignments, and if you look at the week 8, let's say homework in the zyBooks, head over there. What you should see is that there's a number of strings and things that we need to deal with. So let's go ahead and do that. So there's a little bit of a lecture here, lecture 7, strings, which I can download and open it up. And it looks like this. So what are we doing? We can close the sidebar here, make this a little bigger, and then we can get going. So you might have seen this set of lecture slides before because I think I did talk about characters before. So what we need to learn about is Booleans. Well, we just need to know that a Boolean is a true or false value, and strings. So strings is the big deal, but we just want to get to that, look at it briefly, and then head over to the assignment so that we can do the string exercises. So let's actually do that. I'll just kind of skip through this here. So Booleans, so a Boolean is a Boolean value, means true or false. We've been using those in if statements. So you can declare a Boolean like this, like you would any variable. Boolean is raining, but the only 2 values you can set is raining 2 is either true or false. And you just write them like this, all lowercase. Depending on the programming language you're using, they might not be all lowercase. Some programming languages capitalize the T and the F, but not us. It's all lowercase. Okay. Also, and we've done this in if statements here, if you need multiple statements together, you can combine them with ands, which you do with and or, which you do with vertical line, vertical line. And so we hopefully went over this previously, but I think we did in the if statement stuff. All right, we learned about equals, equals, greater than, etc. I know we already did that. All right, now we're talking about strings. So strings. I believe we have already declared strings before because we read them in from the keyboard. And so when you declare a string, you just say string and then whatever the name of the string you want is. And then you can give it a value in double quotes, right? So I say double quotes there because when you use characters, you use the single quote. So we have to pay attention to always use double quotes with strings in Java, right? So this is 3 strings here, string 1, string 2, string 3, hello world, hello. And if you want to check if strings are equal, and this is a very important point, you cannot use equals equals. So it says it here, don't use equals equals for strings. Even though previously, for other types of variables, you go ahead and you do use this equals equals operator, right? But not for strings. And the reason for that, I can explain. Let me open Eclipse. All right, so we have Eclipse open here. And if I can explain why not to use equals equals for strings. So string is a class, which is a reference type. Okay. Uh, Primitive types we know about int, double, float. We don't use float, but we know about it. Boolean, character, etc. Are primitive types. We know that. Those are the ones that are like built into Java. String is a class. What that means is that it's a reference type. And what does that mean? It means that when you use equals equals, on reference types, it does not compare the value of the two things. Instead, what it does, it compares the memory addresses where those things are. That doesn't generally work for us when we want to compare strings or most anything. All right. Now, how do we see that? Well, let me just do a couple of simple things here. String str1, and let's say it's my name. It's Greg. All right. And let's say we have another string, and we want that one to be Greg. Very complicated, I know. Then we have a third string, str3, but I'm not going to put a value in there. Instead of putting a value in there, I'm going to make the user type it in. So I'm going to say system.out.print, type in I'll say name, and we'll do scnr dot next, which we know is how you read one word. And we need str3 equals that. So with this much code right here, I should, sorry, the Zoom thing's in the way. I'm waiting for it to move so I can click the button. So I can click run, type in a name. I type Greg. I tried to Greg, and then it ends because we haven't done any comparisons yet. But let's put some if statements in. So if str1 equals str2, we're going to print out something. System.out.print line str1 is equal to str2. And then we're going to do the same thing with str1 and str3. Okay, so we're going to be comparing 1 and 2 with equals equals, and then 1 and 3 with equals equals. Let's try it. Now, both of these strings are Greg, and then I'm going to add another one that is also going to be, I can't type, Greg. So if you think about it, both of these things should happen, right? Because we're checking if str1 equals str2, but they're both Greg. And we're checking if str1 equals str3, but they're both going to be Greg, right? I just realized that I didn't actually print the value. Uh, um, oh yeah, I did. str1 is equal to str2. Okay, yeah. Um, I realized that I don't like what I printed. So I'm going to change this real quick. I'm going to get rid of the if statements here, and I'm just going to have print statements, and I'm just going to say this, and then we're going to use our Boolean values here. I'm going to write str1 equals str2 up there. And then I'm going to still that, take it down here, and we're going to do str1 equals str3. So we're actually going to see the true false values this time. So I'll type in Greg again, and there we go. So str1 is equal to str2, true. So these two are equal. str1 is equal to str3, that's false, even though I typed in the same name. And the whole point is at this. Don't use equals equals for strings at all. Okay? If you want to make this work properly, what you have to do is wherever you would do an equals equals, you have to change it. So you don't do str1 equals equals str2. What do you do? You do str1 dot equals str2. So you just have to know that that's how to do it because that will actually check the content of the strings and verify that they're equal to each other. The reason this one becomes true, even though it's equals equals, is because the compiler is smart enough to know that I typed the same word twice. So it can just go ahead and use the same memory location for both of them. And so when it compares the memory locations with equals equals, they appear to be equal. But it could not use the same memory address for string 3 because it didn't know that the word was going to be Greg. So it had to use a different location. So when I type in Greg, it's not pointing at the same word that already existed. It's a new word. It just has the same content. So what do? When you're comparing, you change it to str1 dot equals parentheses str2 or str3, whatever you're comparing. Oh, I keep saying compare. Equals str3. So if I use the proper way of comparing strings, now if I type in my name, they're both true because now Greg is equal to Greg is equal to Greg. Okay. So we have to know about this method called equals. Now, if you are in a web browser, which we can be, and you type Java string reference or Java string methods, you'll be able to quickly find a big list of all the things you can do with strings. And so we already saw how to use equals, right? Compare two strings, return true if the strings are equal, false if they are not. Simple. But the next one we're going to look at is going to be what? Let's find out. Compare to. So compare to compares two strings lexicographically based on the ASCII values. So I think when we looked at characters briefly, there was an ASCII chart. This one looks a bit complicated. I typed that in wrong, but it'll still find it. Find a prettier one to look at. The one in Zybooks is actually fine. That does not exist. They're all ugly now. Open image in new tab. Let's try that. All right, good enough. Um, so the ASCII table has a bunch of characters in the column that says CHAR, and then oops, and then the numbers next to it. So ignore the one that says hex for now. We just want to look at the decimal number. So like capital A is number 65, right? Lowercase a is number 97. Lowercase b is number 98, etc. And every key on the keyboard plus a bunch of others have an ASCII code. So like an asterisk is number 42. A single quote is number 39, right? Z is 90. Capital Z is 90. Okay. So you have to understand that every symbol has a number associated with it. Where's preview? Here. So every number has, or sorry, every character has a value associated with it. And when you do compare to, actually, this is a typo here. This is from the one up here. This is this. What it actually does is this. This is what compare to does. Is it returns a negative value if the first string is less than the second. Now, how does a string be less than a string? Well, it compares the letters, actually compares the numbers that are associated with the letters. So when you compare these strings together, 1, 2, and 3, when you compare string 1, which is apple, 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 and you compare it to string 2, you get a negative value because when you compare apple to banana, banana is bigger. It's bigger because B has a bigger number than A. So A is less than B, right? So read the way it works. Negative if the first string is less than the second. So you get a negative value for apple compared to banana. And you'll get a 0 if the strings are equal. So when I compare apple to apple, I get 0. And we have to use that in the Zybooks exercises, but we will get through this set of slides and then go there. You can get the length of a string by the name of the string dot length, right? So this was the name of the string dot compared to, and then another string. You can get a letter from the string. I think we've already seen this. You can get a particular letter from a string by doing the name of the string dot char at and then a number. And you have to remember how the numbering starts. So the first letter of your string is character 0. That's the index, right? So the index is 0 for the first letter, 1 for the second letter, 2 for the third letter, 3 for the fourth letter. Okay. So like on this example, if you do str dot char at 2, you want to know what letter it is, you have to start counting as 0 up here. So 0, 1, 2. So the V is letter 2, which is the third letter. Okay. And the last thing is concatenate, which is concat is how it is written, but it's to concatenate two strings. And concatenate just means put them together end to end, right? That's what concatenate means. So when you do like str1 equals hello, str2 equals world, and then you do str1 dot concat str2, it just puts them together into hello world. There's not going to be a space between the words because there was no spaces up here in the original words. It's not going to add them. Now, you might be thinking, how is this different than just using a plus? It isn't. You can just use a plus. So you don't have to use concat, but it exists to put strings together. Okay. Now, let me look at our homework, which is here. We do need character operations, so let's go a little bit further in the slides. So character is also a class. Now, char, little char, is not a class. Character, the entire word, is a class, and it contains methods to work with individual letters. So if you were looking at individual letters, you can check if something is a letter, because remember, there are other characters, right? So some characters are letters, some are numbers, some are symbols, some are stuff you don't even see on the screen. So you can check if something is a letter, which will make sure it's A through Z or A through Z small. You can check if something is a digit. Digits are 0 through 9. You can check if something is white space. White space are spaces, tabs, new lines, stuff that you don't see. All right. Now, this is going to show you how to use these things. Now, what you have to be careful of is the way you the way you call the methods for characters is different than the method that you use to call the methods for strings. So just to show you, maybe I can type, well, maybe we'll explain this and then I'll type. So if you have lowercase char, right, ch1 is A, another character ch2 is 5, right, the character 5, not the number 5, and the third character is a space, right? So there's literally type a space in there. Then if you wanted to check if it's a letter, it would be character dot is letter. And then you put in the ch1, which is the character you're checking. Character is digit, and then you put in the character that you're checking. Character is white space, and then you put the character that you're checking. Now, the thing about this is that this does not match up with the way that you do strings. So back over here to where I have some strings, let me just show you. So let's say I just do this. My string is just little g, and let me make a character called ch1, and it's also going to be little g. Now, notice how I have to type these in. I have to type in string one with double quotes around it to make it a string, and I have to type ch1 with single quotes around it to make it a character. That's because characters use single quotes and strings use double quotes. Now, if I wanted to check these, let's say I want to just do system.out.print line. And what am I going to print? Let's just say I want to make this uppercase. The way you make a string uppercase is you do the name of the string, dot, and you do two uppercase parentheses. The extra spaces I have around here, right, is just for visual to make it easier to read the str1 to uppercase. And so if I run this, it should print an uppercase G, right? And it does. The way that you would make a character uppercase is not this, right? So this is what you would think it is, right? If you're copying what you did for strings, this is what you would think. This is wrong. This will not work. You can see the little error thing already there. What you have to do is you have to type in character at the beginning, then two uppercase, and then you can put the character in here, the ch1. And now you get the uppercase G. So that's just the way it is. What happens here is that string is a class, which means the method to uppercase is inside of every string. Every string has a to uppercase method. However, ch1 is not a class. So it's a primitive type. Primitive types don't have methods. So if you want a bunch of methods to deal with characters, they actually had to be put into a different class. That class was called the character class. It was uppercase C and the whole word character. So the method to deal with a character is inside of the character class, and you have to type character dot to uppercase, for example, to use that method. And then it doesn't know what character you want to make uppercase, so you have to pass that in as an argument to the method. Whereas for a string, string is a class by itself. Every string has its own copy of the to uppercase method. So when you do str1 dot to uppercase, it already knows that you're trying to make string one uppercase, right? Because you wrote str1 dot. So you don't have to put anything here in the parentheses. Now, we don't need to think too hard about it. You just need to be aware that there's this fundamental difference in the way that you call string methods and the way that you call character methods, um, so that you don't get super confused when you're trying to do the homework for it. Okay? Uh, Now, having said that, I think we are, here's an example of two uppercase and two lowercase. And I think we're just about ready to start the homework. So the homework in chapter 8 is we'll just start at 8.4 here, and we'll try to work through 8.4, 8.5, 8.6, okay? Not 8.7 yet. So 8.4. So I already did these, but you haven't. So let's look at them. So when we talk about strings being equal, we're talking about being identical. So apple is equal to apple, right? Make that so we can see the answer. Apple is equal to apple. Apple, apples, not equal, right? There's an extra S. Apple pie, those look the same. Apple, apple, not equal, right? The uppercase A and a lowercase a are different. Okay. Then they explain to us how to use equals, where the two words that you're comparing, one of them goes here, and then one of them goes inside the equals. And that's the appropriate way to compare words. So here you can see that they have a user typing in a word, and they use user word dot equals USA to see if they typed in the word USA. All right. So looking at this, if string one is apples uppercase A and string two is apples lowercase a, then if we do str1 dot equals apples, well, str1 is uppercase apples. So this is uppercase apples, uppercase apples. Those are equal. Now, if you do str1 dot equals str2, you're checking if uppercase apples equals lowercase apples. That's false. Now, if you want to check if things are not equal, remember that an exclamation point means not. So it just reverses the truth value of whatever comes after it. So when you see this str2 dot equals oranges, str2 is apples. So apples equals oranges, that's false. But if you put a not in front of it, not false is true. So when you see a not, you just need to make sure that you understand that it is that what you're looking at with an exclamation point is not, right? Means not, negation. All right, a good way to compare strings is equals equals. No. Okay. All right. Now, after that, they are going to explain that compare to method that we talked about. So remember that compare to, it compares the strings, but it's comparing like every letter has a number associated with it. So what they're doing here in this example is they're showing you student name is Joe K, and the blue letters here correspond to these numbers: 75, 97, 121, 44, 32, 74. Those are from the chart, right? They're from here. The red word corresponds to the red numbers. And so if you were comparing them, right, they both start out K, comma, underscore. So the numbers, if you're comparing them, 75 is 75, 97 is 97, 121 is 121, 44 is 44, 32 is 32. But way out here in the whatever letter this is, sixth letter, you get J and A. J is 74, but A is 65. So the first word is actually greater than the second word because this letter is greater than the other letter, right? 74 is greater than 65. J is greater than A. Okay. So when you compare them, you have to compare the numbers. So like when we compare apples to oranges, and you looked at the table, well, they start out with A and O. A is 65, O is 79. O is bigger, right? So O is bigger than A. So apples is less than oranges, right? Correct. Now you have to be careful though, because when you do Mary and Mary, these are not the same word. And lowercase letters and uppercase letters are at different places in the table. So looking at the table, all the lowercase letters are over here and all the uppercase letters are over here. And if you look at the numbers, lowercase are big numbers, 97, 98, 99. The uppercase numbers are small numbers, 65, 66, 67, right? These are in the 60s, these are in the 90s. So what does that mean? It means the lowercase letters are bigger, the numbers are bigger than uppercase. So when you're looking at this, Mary to Mary, this is the one with the bigger number. So Little Mary is bigger than Big Mary, right? The coded value for M is greater, is the way they're saying it. Now, when you do this, banana and Bananarama, they're the same up until these extra letters, right? So the one with the extra letters is going to be bigger. Ah, I thought it was. The shorter string. Oh, I said the this one is going to be bigger because it has more letters. The one with more letters is bigger. Yes, but that means little banana is less than the big word, right? So if they're the same word, but one has more letters on the end of it, the one with few letters is small, and the one with big, like more letters, is big. So little banana is bigger. Sorry, little banana is less than Bananarama. Okay. Write an expression that evaluates to true if my name is greater than your name. So if my name is greater than your name, so when you do this, if the first word is greater, first word greater than the second word, then you get a positive number. So if you want to know when it says if my name is greater than your name, greater. Write an expression that evaluates to true if author name is less than author name two. So author name one dot compare to, we can copy that from the one up above, author name two, and we want less than, so just less than, that should be less than zero. Okay. So we can do this, I guess. We might as well. Organize the lines of code to create an if-else statement. Okay, we're writing an if-else statement that outputs goodbye, ending with a new line if the username is, or sorry, if user string is quit, otherwise output hello. Okay, so we're checking if a word is equal to something, right? We're seeing if they type in quit. So we're looking for if the username is quit. So they give us two possibilities here, but you have to know that this one is wrong, right? Equals equals is wrong. Um, we need the one that looks like this. If username equals quit, that's the correct thing. And if they do type quit, we're supposed to output goodbye with a new line, which is this one that should be indented. We need to make sure we close our if statement. Then it says otherwise. Otherwise means else. So we'll grab an else. And then it says output hello. So we look for the one that has hello with a new line, which is this one, which should be indented, and we need a curly brace. So really all we were doing there was kind of making sure we understand how to do equals to check if somebody typed in a certain word. All right, let's do one of these. I just hit run. I don't know why. I didn't read the thing. But so it says out print the two strings in alphabetical order. Oh, okay. So the key here is to understand that basically you're printing first string plus a quote and then plus the second string, right, to try to print something like this. Or you're reversing it and you're going to print the second string and then a blank space and then the first string. So we haven't written code, right? I wrote comments there. But basically, we have to decide which order we print the two words. And we're supposed to be printing them in alphabetical order. And we're supposed to be doing it assuming the words are lowercase. So you just start out with an if statement, if, and to compare them, we can do first string dot compare to second string. And then in here, we're going to uh, do a print, right? System dot out dot print line. And what are we printing? One of these two things. But which one's correct for alphabetical order? So, oh, actually, I guess I didn't, let's do less than zero here, right? We have to, this is going to give us a number. First string dot compared to second string gives us a number. Make sure that's in parentheses. And that number is either going to be greater than zero, less than zero, or equals. So I put less than. So if the first string is less than the second string, looking at our chart, the numbers get bigger as the alphabet goes up, right? So if the first word is less than the second word, less than, then it's earlier in the alphabet. So if the first string dot compared to second string is less than zero, then the first string is the small word, which means earlier in the alphabet. So that means alphabetical order would be this: first string plus second string. The other alternative would be if either they're the same word or if the second string is lower in the alphabet. So one of these is correct. It's going to print them in the correct order, hopefully. If we got it wrong, then that would just mean that I reversed these on accident and I could just easily fix it by, switching these two print statements around. But in this case, we can see that we if they type in two different words, then you get them in alphabetical order. Two different words, you get them alphabetical order. Two different words, you get them alphabetical order, sort of, right? Except that this is, uh, a bigger word. And then if you do the same word, it doesn't matter what order you put them in, but it'll look fine. So anyway, that was mostly about equals equals and compare to. So let's move on. So we're in the next section. So this one's actually, I think, easier for people. This is just counting indices, right? So we have to remember that the counting for the index starts at zero. So like Mary is index zero is capital M, then index one is A, index two is R, index three is Y, right? So know that, I guess. What is capital L's index? Zero, right? What is I's index? Well, 0, 1. What is T's index? So we just got to start counting. 0, 1, 2, 3, 4. Index 4. Spaces count. So a space is still a character. So when they say what character is at index 2, we start counting at 0. 0, 1, 2. Actually, the space is index 2. So space is index 2. For the string you wish, which character is at index 4? Again, start counting at 0. 0, 1, 2, 3, 4. Index 4 is the W. Index 9, 0, 1, 2, 3 for the space, 4, 5, 6, 7, 8 for the exclamation, 9. Uh-oh, there's no 9. There's no 9. Okay, now to get a particular character, we use the character at, char at. So You can get any letter you want from the word using character at. So back here, for example, let me just put in a word. So there's a name. And if I do str1 dot char at, and I put in 0, we get lowercase g, index 0. If I put a 1, save it, I get r, right? Character 1 is lowercase r. So you can get any letter you want by putting a number in there. So you have to put a number in to the method char at. All right. So if the word is run and you do user string dot char at 0, you're going to get the uppercase R. If you do user string char at 3, well, that's going to be 0, 1, 2, 3, the exclamation. Char at 4, well, we just saw, right, like 3 is the last letter. So when you try to access index 4, it's not blank, you get an error, right? So if I go back to my name here, if I try to access character 6, I get the Y, last letter. If I try to access index 12, there is no letter 12, right? So I just get this error, and the error says index 12 out of bounds for length 7. So it tells me how long the word was, and it tells me that my index was out of bounds. So that's a helpful clue. Now, one thing is that you want to keep from doing this, right? We don't want to make errors. So you need to know how many letters are in your word. So you could do this int like word length, that's just a variable, right? Equals, if I want to get the length of the word Gregory, I just do str1 dot length. And that's the how long the word is, right? So I could print the word, or I could print the word length now, right? Word length, and tell me how many letters are in my word. So there's 7 letters, 0, 1, or actually 1, 2, 3, 4, 5, 6, 7. 7 letters, right? 7 letters. Now, you might think that if you want the last letter, that you would just do, well, str1 dot char at word length, right? You would think that that would work. You'd be like, yeah, we got the length and we're going to access that letter. And you get an error. Index 7 out of bounds for length 7. And that's because you have to remember that indexing starts at 0, right? So if there are 7 letters, 0, 1, 2, 3, 4, 5, 6, the last letter is actually 6, index 6. There's 7 letters, but the last index is 6. So there are 7 letters, but the last index is 6. It's always one less. So that's why when I try to do str1 dot char at word length, I get an error. To actually get the last letter, I need the length minus 1. I need the length minus 1. That'll be the last letter, which is Y. And I can change the word now, and I can say, this is a sentence, exclamation, and I'll still be able to get the last letter, or in this case, it's a exclamation point. So you need to get the length and then subtract 1 to get the last index. That's important. Okay. So they're going to explain this all to you. What is the index of the last letter in hey? 0, 1, 2, 2. What is the length of the string hey? 1, 2, 3, 3. right? Last index 2, length 3. Is the string's length the same as the string's last index? No. Length is 1 greater. Okay, they really want to make sure you understand this. So user text dot length, what is it? Well, we have to count 1, 2, 3, 4, 5, 6 for the space, 7, 8, 9, 10 for the other space, 11, 12, 13, 14. There looks like there's 14 characters. Yes. What is the last index? 13. Okay. What character does user text dot char at? We're getting a character. User text dot length -1 return. Well, whenever you see the length -1, that should be a clue that you're getting the last character, right? That's just what I did in my example. So last character, which is a 4. Okay. All right. Concatenate. What does concatenate do? It just puts strings together. So if you have user string is done and you do user string dot concat exclamation, you're going to get done with an exclamation. It just puts the exclamation on the end. That's it. If you do user string dot concat question mark, you're just going to get done with a question mark. Ah, there was a mistake here. I was not smart enough. So look at this. We're concatenating strings. Concatenate strings. Strings are typed with double quotes. This failed because this is not a string. This is a character. A character and a string are different. So in order to make this work, it had to be double quote, and it was not. So this is you get an error when you do that. But that's a really sneaky error. It's really easy to not notice that. All right. Now, we're used to using plus. So if you do user string plus now, you're going to get done now, right? That also does concatenate. If you do use user string plus equals later, that's also going to concatenate, right? When you do plus equals, that's just a shorthand notation for like user string equals user string plus, right? We've seen this before. You can call the strings by name. So done yet dot 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 dot. Uh, Actually, it's not done yet dot 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 because there's no space there. So it's going to be done yet. They would need to type a space if they wanted there to be a space. All right. They're going to make sure you really understand this issue of the length of the string and the index being one off from each other. Does user text.char at 7 yield y? Let's find out. Count at 0. 0, 1, 2, 3, 4, 5. No. User text.char at 7 is not y. That's an error. Does user text.char at user text.length yield y? No. Remember, you have to take the length and -1 in order to get the last letter. All right, let's do challenge activity. Let's do number 2. 2. What is it? So, given string user string 1 on one line. All right, there it is. And string user string 2 on the next line. There it is. Assign length diff with the length of the shorter string subtracted from the length of the longer string. So the problem here is that we don't know which string is longer in general, right? Like, because they could type the words in whatever order they want. So this is actually a bit sneaky. So first we have to do an if statement. If, and we need the length. So user string one dot length, if that is uh, greater than user string two dot length, then what? Well, we're trying to assign length diff to be equal to um, shorter string subtracted longer string. So like ornament and melon, when you subtract how many letters there are, you get 3. So ornament has 3 extra letters. So you need to subtract the big string minus the little string. So the length diff is going to be, in this case, the big string is user string 1. And we would subtract the length of user string 2. Now, if we were wrong about, or sorry, if user string 1 dot length was not bigger than user string 2 dot length, then the other word is the bigger word, and we should change this to this way. Now I'm going to do this, and then I'm going to write this in maybe a more concise way. I've got I'm missing a set of parentheses here. All right. So it worked, but I don't really like the way that I wrote this. So I'm going to write it a different way. Just going to comment this all out, and we will write it a different way. So one thing we could do is we could take this length diff and we can just make it to the length user string 1 dot length minus user string 2 dot length. And then that's either a positive number or a negative number, depending on which way we subtracted it, right? Like if you do 5 minus 3, you get 2. But if you do 3 minus 5, you get minus 2, right? So when you do this calculation that I just did, either it's positive and we did it the right way around, or it's negative and we did it the wrong way around. So we just have to fix the number we could say if the length diff is negative, then we did it wrong. So to fix the sign, we would just add a minus to it, right? Because if it's negative, then we do a negative negative to make it a positive. So I feel like this is easier to understand than a whole if statement down here, but maybe I'm wrong. I don't know. But anyway, we did it. Let's try number 3. Given string user input, there it is. And string to add, there it is. Assign concat string with a new string of user input appended with a hyphen. So if they type funny koala, we need to make the word funny koala. This is so easy. So what's our final word? Assign concat str. So concat str, it's supposed to be the first word, which is user input, I think. Yeah, first word is user input. Then we're supposed to have a hyphen. And then we're supposed to add the second word, which they called the second word to add for some reason. So there you go. Now, can you use the concat method? Yes. But you could also just use plus. So I used plus. Another way to do this would have been concat string equals, and we could do actually concat string dot concat. That's the name of the method. We need to concat a hyphen, and then another concat. You can just put them in order, and then we would do the to add on the end. So this will be concat string concatted with a hyphen, concatted with a to add. So the same things that you see up here, just written with the other concat syntax. What? Oh, sorry. This was supposed to be user input. We're starting with the user input and we're adding on the end. User input dot concat hyphen concat to add. I don't know why I didn't notice that this word was not this word, but there you go. Anyway, both methods work, so you have a choice between using the pluses or using the concat operator. All right, character operations. So you see here, we've talked about them a little bit. You can check if something is a letter, if it's a digit, if it's a white space. You can make things uppercase. You can make things lowercase. All right. So character dot is letter 7. Is 7 a letter? No. Character dot is letter user string dot character at 0. Okay, so user string is up here. This is it. What's character 0? It's H. Is H a letter? Yes. Now, white space, remember white space is like spaces, tabs, etc. So character is white space user string dot character at 3. What's character 3? Have to count at 0. 0, 1, 2, 3. Hey, character 3 is a space. Space is white space. Character is digit. Character at 6. 0, 1, 2, 3, 4, 5, 6. 6, digit 6 is a question mark. That is not a digit. All right. Character dot to uppercase. User string character at 1. Okay, start from the inside. What is user string character at 1? 0, 1. Lowercase e. So this is a lowercase e, but we're doing to uppercase. So if we do character dot to uppercase on a lowercase e, it turns it into an uppercase e. Character dot to lowercase user string character at 2 yields an error because y is already lowercase. No, if you try to make something lowercase that's already lowercase, that's fine. It just doesn't do anything. So you will not get an error for that reason. Character to lowercase user string character at 6 yields an error because question mark is not alphabetic. Ooh. Would that be an error or not? Well, that just is down to what they decided to do when they made when they tried to make Java. Um, what happens if you try to make a question mark lowercase? Does it leave it alone or does it give you an error? Let's find out. No error. Yeah, there's no reason to, right? Like if you, because you can imagine that you had a bunch of letters and you wanted to go through and make them all lowercase. You wouldn't want error messages to pop up just because you happened to check something that was not a letter. You would prefer it just to leave it alone. So no error messages there. Just it ignores it if it's not a letter. All right, let's do this. Let's hit start. Variable in string is assigned with a two-character string. Okay, in string has two characters. Cool. If in string second character is alphabetic, output the character is alphabetic. Okay, so it hard part is parsing what they want you to do. Now, I can see this though. If in string second character is alphabetic, right? So I know I got this. If and in order to check if a character is alphabetic, it's character dot is letter, right? So I can tell I'm starting to think about this. Is something a letter? Now, specifically, it says if in string second character. So how do I get in strings second character? Well, that is in string dot character at, and the second character, remember the counting starts at zero. So first letter is index zero, second letter is index one. So that's a one for the second character. So character is letter, in string character at one. So this is the second letter, and we'll check if it's a letter. Cool. So I think that we did the if statement right. So it says output this, and it says followed by the alphabetic character. So we would do a system dot out dot print line, I assume. The second letter is alphabetic, and then it says followed by the letter. So we have to do plus um, the letter, which is in string character at one. So I think that's right. And then it says otherwise output the second character is not alphabetic. So otherwise, that means else system dot out dot print line. Is there a typo here? Yeah, I'm missing a quote. Second character is alphabetic and then the letter. Otherwise, the second character is not alphabetic. So, like, kind of putting these things together here to get the second letter and then checking if it's a letter, like putting, you have to write a method inside of a method. That's kind of the key there. All right, we'll do number two and then we'll stop. Think we did a long lecture today. Variable in string is assigned with a three character string read from input. If in string's first, second, and third characters are all not digits, output valid string. Okay, so this is not strictly hard. And you can make this easier. So, you know, I would, what do you want to do here? Um, so you can kind of separate this out into separate parts and make your life a little bit easier here. So like I could do like several Booleans. I'm actually gonna just erase those and do one and then replace it. But so like I could do this like so like first valid. What are we doing? So we're gonna check if first, second, and third characters are not digits. So um actually, maybe we'll do this. Like we'll say uh, digit one is what I'll do. So if I want to check in strings first digit to see if it is a digit, that would be character dot is digit. What are we checking to see if it's a digit? We're checking in strings first digit, which is character at 0, right? So this would be checking if the first letter is a digit. Then if I want to check the second letter to see if it's a digit, and maybe I'll change this to a 0 actually. So it's 0 here and then 0 here. And then for the second letter, digit 1, 1. And then for the third one, 2, 2. So right now, these are all going to be like this is going to be true if first character is digit, right? And then similarly for the others. But the point is, this is true if it's a digit. Once I've got all those, then it says if, so we need an if statement. And it says if the first, second, and third characters are all not digit. So that would mean if not digit 0, right? I say not because digit 0 is if it is a digit and we want it to be not a digit. So if not digit 0 and not digit 1 and not digit 2, then they're all not digits, right? So if the first letter is not a digit and the second letter is not a digit and the third letter is not a digit, then they're all not digits. Then we should output valid string. So we do system.out.println valid string, and then there's probably an else. Um, we output invalid string. Now, hopefully, how would you have written this if statement if you were trying to do all of this inside of here? It'd be a really long line. And that's why it's important to understand that, you can break this apart and we can kind of check each letter individually to see if it's a digit before we go and we write the if statement. And then the if statement can be a little simpler. Now, you'll probably have a different one than this, but you can apply the same idea. All right. So I have to go now. I think that was a longer than usual lecture, but we got a lot done in terms of the exercises. So with that said, I'm just going to go ahead and stop the recording here. Have a nice day.